In the previous video, we created an empty repository on GitHub from scratch. So we can see that at the end of that, we've got this list of useful instructions from GitHub on how we can use this repository. So what we want to look and focus on is this middle section here on pushing an existing repository from the command line. And since we've already got an existing Git repository that we've created on our computer with some source code in it, this is the section we need to refer to because we want to push that code from our computer to this remote repository, in this case the GitHub repository we created in the previous video. Now this is the URL that I've got here for my GitHub account and the repository I created. Now in the case of you creating your own account and repository, you'll obviously have a different URL to use, the URL that you received after creating your account and your own repository. So I'm going to take a copy of this one though. This was the one that I used and got in the previous video. I'm going to copy that because we're going to need that shortly so that we can push our code to this remote repository. All right, so I'm going to take a copy of that. Now before we go though, you might have noticed this line up here, quick setup. If you've done this kind of thing before, we've got HTTPS and SSH over here. Let's just go through that briefly and see what that's all about. Now the one that we've copied here is HTTPS, which is just a secure way to get access to a particular URL. So it's the communication protocol between our local repository and the GitHub repository, or will be once we actually start using it. Now GitHub gives us two ways to access our repository. We can use this HTTPS, and I'm sure you've probably seen that before when you've connected to your bank or some other secure site. But we can also use this SSH communication protocol as well. So if you click on SSH, notice that the link changes from what it was before, and we've now got a link that can be used with SSH on the command line. Now SSH means Secure Socket Shell, which is a secure communication protocol that can occur between a client and server, and not necessarily just a version control system server or client software. But in this course, we're only going to be dealing with HTTPS because it's really all we need to look at. So I'm going to go back and leave that clicked, or in any event, I'd already copied the link anyway, so we're good to go. And the other thing up here I just want to briefly mention is set up in desktop. GitHub's actually got the GitHub desktop, which is a graphical based version control system client available for Mac and Windows. Unfortunately, there's no Linux version. The best part about that is that it's free, and we may look at doing a video for that later on. We'll see how we go with that if you want to get access to that particular software. But what we're going to be doing now is working with the command line to push our source code to the remote repository, because that's something everyone can do and is certainly recommended to learn the basics before we start sort of focusing on specific software. All right, so we're finished with our browser now. We've got a copy of the URL. I'm going to minimize that. And let's open a terminal session. And we're going to go back to our Git repository folders that we've been working on the entire time. And we want to go into our converted Git repo. And that's because we've got some software there that we can use to publish. Now, before we connect with GitHub, let's start the Git remote, or use a Git remote command. And what this does, it lists all the existing remote references and their details. And here, when I'm talking about a remote reference, I mean a reference or a pointer to a remote repository. So I do a git space remote space -v, and we get nothing back, which would be correct because we haven't previously established any connections to any remote repositories. All right, so now let's paste the line we copied on GitHub of the landing page of the GitHub repository that we created in the previous video. So I'm going to type git remote add origin, and then I'm going to paste in that URL that I got from the web page. And for some reason it didn't paste, so let me just go back to it again. Now I'm only copying the URL, but I could have actually copied that entire line with the rest of the commands. I've just typed those in manually. Either way is going to give us access to be able to push our code to that remote repository. But because I've already typed the first part of it, I'm just going to copy the URL and paste that in. All right, I'm going to press enter there. So let me explain what this actually did. So git remote, well, that's the remote command used for managing remote connections in Git. And when I use the add command there after the git remote, we've seen that before. It's just a sub command of the main remote command, and add is what we normally do when we're adding files to a repository. Now origin is the remote reference or pointer that represents our remote repository. Now note that origin is not a special keyword as such. It's just a tradition to name remote references as origin in the Git user community. So instead of origin, we could have named it anything else like my remote reference or anything else along those lines. But to honour that tradition and to keep things consistent, I've used the word there, origin. Now, as you can see, obviously when I did that command and pressed enter, there was a brief pause, but we didn't actually see any visible output. And usually when the execution of a git command doesn't produce any visual output, then you can assume all is well. Otherwise, Git would have thrown an error message, and you've seen the errors that we've had in the past or when things have worked correctly without any extra output. Now, if you are really still curious to know what's going on, if all went well with our earlier command execution, then you can use the -v as a parameter to get a more verbose amount of output. So verbose here means that Git will produce more expressive output and not remain silent in the case of something going well, which can be useful for debugging purposes or when you're sort of new to Git and wanting to find out what's happening behind the scenes. So again, if we just type git remote here now, we can see we've got something there, very basic output. It says origin, but then if I append a -v on the end of that, you can see we've got more information showing on the screen there. So we can see that origin is mapped to the remote repository URL that I copied from the web page. And you can see that the same URL was mapped twice, once for the push command and once for the fetch command. Now our main focus here is the push command only, and we'll be talking more about push shortly. But in most cases, fetch and push usually use the same URL. So in some certain situations they might be different, but we won't really be going into detail for fetch because what we're needing to achieve here, we can really use push for that purpose. Essentially, the fetch command pulls artifacts into your local repository from a remote repository, and whilst push does the opposite. So it's actually getting artifacts from your local repository and sending it through to the remote repository. Now there are some other differences, but the bottom line is we can focus on using push for now. All right, so now that we've established connection from our local repository to the remote repository, we've got this source code that's in this local repository that we want to upload, or push it to be more precise, using Git terminology. So let's add the second line now, and we could go back to the web page if we wanted to and copy that because that was also shown on the screen, but I'm just going to type it in here. So the git push -u space origin space master. So git push is the command for pushing changes from the local to the remote repository. The -u option sets up a tracking branch relationship. So this ensures that next time you push changes, you don't need to explicitly use the origin master part of this line. You can just use a push. All right, so let's do that and press enter. So it's prompting us for username. So we need to enter the GitHub username, remembering that when we created and registered an account with GitHub, we specified a username and a password. So let's enter that to use the details and password now. So in my case, it was Tim-Bachowka. I'm going to enter my password. Notice when I'm typing there, it's not actually showing the output as I'm typing. It's got that little picture of the key there to denote that it's secure. I'm going to press enter now. And if I've got my password and username correct, we can see that it's now, as it is doing, it's uploading that information. So what's actually happened here, we're looking at the output that we've got back. So we've got this delta compression using up to 8 threads there, and that number might change for your computer, but what's happening here is Git is compressing objects prior to pushing them up to GitHub. That's so that your uploads are faster. So delta compression is a special compression technique whereby Git pushes up the file changes which Git is using to make it a bit more optimal. So delta compressor is this special compression technology, or their technique, to push up the file changes as quickly as possible. And on my operating system, it says up to 8 threads to get the job done. And basically, it's just a number of processes that it used to get the contents up there as quickly as possible. Now, where it's got writing objects, 100% 50 of 50, that's just telling us what was actually sent through and approximately how fast it was actually sent through. And the total 50 delta 8 Again, you don't really need to know too much more about this other than the fact that it's actually sent the remote repository, or the remote repository to be more precise, has been updated with the contents from the local repository. And it's given a confirmation of the GitHub link to this particular username and then the repository that we created. And you can see down here, then the second to last or third to last line, new branch is created, a new branch on that remote repository as well. The bottom line here is now the branch master is set up on GitHub, and it's a copy of what's in our local repository. All right, so let's go back to the browser and just check out what's happened. So let's just do a refresh here. And you can see now that I've done that, we've actually got some files showing here. And you can see here that Tim Bachaka first commit in the new feature branch, and all the source code that was in our local repository has now been uploaded to this remote repository. And we can go into a particular folder if we want to, and we can see that the files are there, and I can click on that again. You can see that that is a file that came from our local repository. And I can go back just by clicking on the main link to the repository to see that the information's there. We can also see that it's got one branch, and that's the branch that was created automatically when we uploaded it, and that's the master. And you go back to that, and the other thing it shows here is 7 commits. So all these commits that we made locally have been transferred to our remote repository. Remembering that when we actually do a push, it's actually pushing and confirming all the initial commits that we've done in a branch. And the times here where it says it's committed a day ago, that's when I created the video for that step. So you can see then what it's doing is it's sort of kept a mirror image of what that commit history is, and it's transferred that commit history over to this remote repository on GitHub. And there's also, there's quite a few things here that you can actually have a look through. And again, if I just go back to commits again, we can click on a particular commit if we want to do that. You can see it's giving us quite a bit of information, who the original committer was. We can preview files. In this case, there's nothing to preview, but note here also, if this commit is yours, make sure that my email address is associated with your account. Now what that means is that I've used a different email address to register this account than I have when I used the email to create the local repository. So I can click on this button to actually claim that, to associate that other email address with this account as well, which would be a good idea. So you can see there's quite a bit of information that we've got access to here. We'll just go back to the the main Git Bootcamp repository. There's lots of bits of information that we can actually find. Issues, pull requests, projects, all sorts of other things. So there's quite an abundant amount of information that GitHub actually track relating to our repository. But the bottom line here is now at this point, what we've done is we've completed this push, and the local repository has now been copied effectively, or cloned if you will, via that push to this remote repository on GitHub. All right, so I'm going to finish this video here now. In the next video, now that we've learned how to push content to a remote repository, we're going to do the opposite. We're going to be using the pull command, and that's grabbing data from the GitHub repository and pulling that back down to a local repository. So I'll see you in the next video.